Hi everyone. In the last class, we studied about the atomic radius, right? So today, in this video or in this class, we will move towards ionization enthalpy, or we can say energy. Both are same. One you can call this as enthalpy, or else you can call this as a energy, right? Both are same. So dear students, here ionization means breakdown, very important. So first we need to understand what is the meaning of this word. So ionize means break, right? Break, or we can say remove, very important. See, during offline classes what we discussed is that in an atom there is a nucleus, and to that nucleus electrons are always revolving around that nucleus. The electron always revolve in their particular path, right? So now what I said is this part, that means the nucleus part is very rigid. Rigid means very tough, we cannot break it, right? That means in a nucleus we have positively charged species as well as neutrons. That means proton and neutrons. So if this nucleus is very rigid, then one, we cannot remove or we cannot add the protons into the nucleus. But in elements or in any atom, what one we can do is that one we can remove the electrons or one we can add the electrons. That work we can do with the atoms or elements. But this part is very rigid. You all know, we have already discussed during the class. So my intention is to, why I am taking this example means, see, if the nucleus is very rigid, means whatever present in the nucleus, we cannot remove, right? Whatever it may be a proton or it may be a neutron, right? So, but the outer part always, when we can add the electrons, the outer part is always consists of what? Electrons. When we can add the electron or when we can remove the electron, this process we can do with the elements, but we cannot add or remove the protons, I mean nuclear charge, right? So that means ionization enthalpy. So ionization means, already we have discussed, break or remove. So to remove the valence shell electron, we require some amount of energy. That energy is nothing but what? Ionization energy. See, let us take an example. There is an electron, and consider this as a valence shell itself, right? So first cell is itself a valence shell in this particular example. But we can take an example as hydrogen, right? So I want to remove this electron from the what? Hydrogen, from the nucleus of a hydrogen, right? So if I want to remove this, I require some amount of energy, right or no? Yes or no, right? So we require some amount of energy to remove this. That amount of energy, whatever we are requiring to remove the valence shell electron, very important. The last shell electron we can call, or valence shell electron. So to remove this valence shell electron, we require some amount of energy. That amount of energy is nothing but the ionization energy, right? Today we are going to see the same case what we saw in case of atomic radius in group as well as in the period, right? So see, ionization energy, I repeat, the amount of energy required to remove the valence shell electron or the valence electron or the outermost shell electron is called ionization enthalpy, or else one we can say ionization energy, right? So now consider any group in the periodic table. You can consider any group. So if you see the trend of ionization energy in one group, then in all other 17 group, I mean, they are having the same trend in case of group. If we move top to bottom, then whatever ionization we are seeing in one group, the same thing will see we will see in other group also. So this is the more basic thing. So consider again the same group. You can consider lithium, I mean hydrogen, lithium, sodium, potassium, rubidium, cesium, and the francium. Or else you can say hydrogen also you can take. So now while moving from top to bottom, so in the last class what we saw about the atomic radius is increasing, right? Don't forget that atomic radius. That is very, very important, right? So now if we move down the group from top to bottom, then what was happening? The atomic radius is goes on increases. Why? The reason is due to the electron enters into the new shell, or because the electrons are entering into the new shell. So that's why we saw in group the atomic radius will always increases. What about ionization enthalpy in group? Whether it increases or decreases, we will see. So the amount of energy required to remove the valence shell electron, right? So I will I mean, we know about the group. In group, atomic size increases, right? So I will take two examples. I mean, two atomic radius example. After seeing these two, one we can come to know very easily what is what amount of ionization energy requires in case of the electron which is very near to nucleus. This you can call as first case, and this you can call it as second case, right? What I did is I took two examples. I mean, in first example the electron is very near to the nucleus, but in case of second example the electron, I mean the valence shell electron is little far away from the nucleus as compared to the first one, right? So here, see, again I remind you, ionization enthalpy or energy is nothing but the amount of energy required to remove the valence shell electron. So now, before going to see ionization energy, the amount of energy, first you consider these two cases. In first case, the electron is very near to the nucleus, right? You can very easily see. But in second case, the electron is far away from the nucleus. So now, dear students, because this electron is very near to the nucleus, right? The electron is very near to the nucleus. On this electron, there is a good to hold on this. On this electron, there is a good to hold on this nucleus because of because of they are very near to each other. If they are near, nucleus and the electron, then definitely nucleus will hold that electron very tightly. Why? Because of less distance between them, right? Are you getting? Okay. So now consider this case. Second example. Here the electron is far away from the nucleus. That means we can imagine that if the electron is moved away from the nucleus, then definitely the hold of this nucleus on this electron will be very, very less as compared to this. Or else here the bond between nucleus, in other way we can explain this same concept. See here, the bond between the nucleus and this electron is very strong. Why? Because they are very near. Very simple. And the bond between this electron, this nucleus and this electron is, not so strong. Why? Because the distance is more. Now tell me what happens. To remove first electron or second electron, we require more amount of energy. Definitely for first electron. Why? Because it is very near and it has a good influence. The strong bond with the nucleus. So that's why it requires a huge amount of energy to remove. But in case of here, we require a less amount of energy as compared to this. Why? Because it has moved away from the nucleus. So this is the trend. As the atomic radius increases, ionization energy, what happens? Decreases. See, atomic radius is less here in case of first example. But in case of second example, the atomic radius is large. More. So what happens? If the atomic radius is less, we require more amount of energy, right? If the atomic radius is more, atomic radius, if atomic radius increases, then definitely what we are requiring, we require a less amount of energy to remove that electron. Why? Because of the bond between them, because their distance is more, so that's why their bond is not so strong like in case of first example, right? So this is the trend one we can say. So but what was happening with the atomic radius in the group? It was increasing means it is just opposite of what? Ionization energy. That means if the atomic radius increases, we require less amount of energy, less ionization energy. So that means as we move top to bottom in the group, ionization energy decreases, right? Very simple. Decreases. Why decreases? Because the atomic radius is increasing. The reason is, here you can say, as the atomic radius increases, the ionization energy goes on decreases. The reason is, atomic radius increases due to atomic radius increase, or because atomic radius increases, you can say like this, right? So because of atomic radius in group, always the atomic radius increases. In the last class we had seen, due to this atomic radius increment, what happens, that electron moves away and away from the nucleus. As the electron move away from the nucleus, definitely we require less amount of energy. Why? Because nucleus and the electron distance will be increased. So if this increased, nucleus and the electron distance, then definitely what happens, this electron, the away electron, which is very far away from the nucleus, which will be not having so much strong bond with the nucleus. If it is not having so much strong bond with the nucleus, then definitely we can easily remove this electron. So this is ionization energy in case of group. So finally we will see in case of period. So period means left to right. So see, again, we can compare this ionization enthalpy with the atomic radius. So that's why during last class I have requested you to understand completely go through that atomic radius. So why? Because the other properties of the periodic table totally they are depend on the atomic radius. If you come to know about the atomic radius, then definitely it will be very easy for you people to understand the next property like ionization energy. So in case of period, atomic radius decreases. Why? Due to the due to entering of electron into the same cell, right? So if the electron enters into the same cell, the density of electron increases on that particular cell or in that particular cell. So that's why the valence cell will shrink. gradually, right? Atom by element by element. So if the ionization energy decreases, so this is the first case and this is the second case. So here we took opposite formation, right? So in first case, see, the electron is somewhat far away, I mean away from the nucleus if I compare this electron with this electron nucleus distance. So now if the electron is having a good distance with the nucleus, then definitely already we saw in case of group we can very easily remove. But if the electron comes nearer to the nucleus, then it will be very difficult to remove that electron. I mean, we require extra amount of energy to remove that electron. Why? Because as the electron comes nearer to the nucleus, definitely the bond, strong bond formation takes place. Due to that strong bond formation between the nucleus and the valence electron, it will be very difficult for us to remove that particular electron. So that's why in case of period, our atomic radius gradually decreases element by moving from left to right. So thus from carbon to nitrogen, nitrogen to oxygen, oxygen to fluorine. If I compare these two elements atomic radius, then carbon is having little more size as compared to the nucleus, I mean nitrogen size. Likewise, if I compare this nitrogen size with the oxygen size, then definitely the oxygen is having lesser size. Why? Because the number of electrons are increasing. Now, if we come to our concept, that is ionization enthalpy, then this nitrogen requires more amount of energy to remove the electron. If I compare with this, that means, see, as if we move from left to right, the size is decreasing. Size is decreasing means the electron is coming near to the nucleus. As the electron comes near to the nucleus, then it will be very difficult for us to remove that electron. That means in periods, always the ionization energy increases. Why it is increasing? The reason is due to decrease in atomic size. Reasons are very important here. Reason is due to decrease in atomic size. Right? Very simple. So that's why I am again requesting you, please go through this, I mean atomic radius. So if you come to know about atomic radius, then these properties are very easy, will be very easy to understand, right? So this is all about today's class. In the next class, we will see one more new property of element, right?